Welcome to this video on graphing the sine and the cosine function. Now, at the start of the topic of trigonometry, we pitched trigonometry to you as a tool of analyzing triangles, namely the behavior of the angle here relative to the sides. So say if you had two known sides, then you would be able to deduce the angle within the triangle, or if you had one known side and the angle within the triangle theta, you could deduce the other two unknown sides. And the way in which you did that was using the sine, cosine, and tangent ratios. So what we're going to do today is we're going to take a step away from looking at these ratios here as actual ratios, and we're going to take a more mature look at trigonometry and start thinking of them as functions. So by functions, I mean, consider if we've got f of t, we could define f of t as, say, sine of t. And since this is now a function, we want to understand what would be the behavior of this function f of t over a range of values for t. So recall back to the concept of the unit circle. So we've got a string, let's say. So we've got a string, and our string is of length 1, and we want to sweep our string, holding it at this point here, 0, 0. We want to sweep this string across a range of 0 radians to 2 pi radians. So notice that a string is going to spin around like such. Now the behavior, or the shape that this string is going to draw out or trace out, is going to be a circle. So hitting play, notice that we're drawing out a circle. So this circle, remember, we call this the unit circle. And what we want to know is that if we've got a unit circle, what is our coordinates as we sweep across this range of angles? And we know that it's going to be between 1 or -1 and 1 on the x-axis and -1 and 1 on the y-axis as well. But more specifically, when is it going to be those values across those axes? Now, we can work out the x values and the y values. So say the distance from here to here, so here to here, we can work that out. Whoops, wrong one. Here to here, we can work that out using trigonometry, because we've got the angle in here, and we can work out this vertical distance from our x-axis here. And similarly, we can work out the distance from here to here using our cosine function, as we've got our angle here, and this side here in blue, this is the adjacent, and the one in here is the green. So this green one, this is going to be the output of the sine function. So say, for example, if we've got a value of, let's go 0, then our sine function is going to output a value of 0, and our cosine is going to output a value of 1. Now, what about if we had, say, pi over 6, so 60 degrees? If we put that in our calculator, we're going to get √3/2 for the output of our cosine function, or 0.866, and 0.5 for our sine function. But more specifically, let's take rather than looking at specific values, let's take a more of a simplistic view. We'll firstly look at the sine function here, and we'll ask ourselves, for what regions, so what quadrants I should say, what quadrants is the sine function going to output positive, and what quadrants will it output negative? So if I sweep the function, where is it? If I sweep it over, let's change that back to a variable. If I sweep it over a value of, let's say in our first quadrant, we're clearly positive. And in our second quadrant, notice that the sine value, it's still our vertical component, it's still above the x-axis, so we're still positive. And down here, we go into the negative, and so third quadrant we're negative, and then in the fourth quadrant we're also negative. So jumping back to our OneNote document. So looking at our OneNote document, if we're looking at the behavior of the sine function, so behavior of sine t, we're going to see that in the first quadrant we're positive, the second quadrant we're still positive, and third quadrant we're negative, and the fourth quadrant we're also negative. So from this behavior alone, we've got a rough understanding of how the sine function is going to behave. So if I go down a little, what I've got down here is I've got some graph paper, and we'll say function of t is here, and we'll say t is along this axis. And what we want to do is function of t is equal to sine t. Now what I've also done is I've broken or segmented this graph up here such that we're in quadrant 1, so Q1, Q2, Q3, and Q4. And what we saw from above is that for quadrant 1, we're expecting positive values. For quadrant 2, we're expecting positive values. But for quadrant 3, we're expecting negative values. And for quadrant 4, we're also expecting negative values. So what we'd expect is maybe something like a graph that maybe looks something like that. Now, this probably isn't satisfactory to say that this would be this function here. So let's go up again and let's ask ourselves, let's get that right. So let's ask ourselves, in this quadrant, so quadrant 1, quadrant 2, quadrant 3, and quadrant 4, is sine increasing or is it decreasing? So jumping back over to our unit circle, let's have a look. So in quadrant 1, notice we're starting off a sine value of 0. And as we sweep our way up to pi on 2, we get a sine value of 1. Whoops. So what we can see in quadrant 1, we're increasing from 0 to 1. Then from pi on 2, we start decreasing in value. So from 1, we start going down to 0. So back to 0 roughly. So second quadrant, we're decreasing. Third quadrant, we're going from 0 all the way down to -1. And then fourth quadrant, from -1 back up to 0 again. So going back over to here, in the first quadrant we're increasing, and in the second quadrant we're decreasing. The third quadrant we're decreasing even further, so we're decreasing below 0, and in the fourth quadrant we're increasing back towards 0 again. So going back down to our rough idea of the graph, what we're going to find is we're increasing here. So we start off at 0, remember, and we're going up to a target of 1. So I'll do this in red. So we're going up something like that. In quadrant 2, we're decreasing. So we're decreasing down to 0. Then quadrant 3, we're decreasing down to -1. And then in quadrant 4, we're increasing back to 0. So this is sort of starting to look like a sine graph, but the shape itself isn't quite right. What we need to know is how fast are we increasing? So let's go back to our unit circle once again, and let's examine. So let's put in values of, say, we'll go pi on 2, not pi on 2, pi on 6 we'll go. So notice that pi on 6, we're going to get a value of y equals 0.5. So let's go back over here. At pi on 6, roughly here, we're going to get a value of half. So do this one in. Let's go to, we'll get rid of our black line here. And we'll go back to black. There. Now, let's say pi on 4. So halfway between, we're now at 0.7071. So jumping back, 0.7071. So that would be roughly somewhere around here, I guess. And then let's go pi on 3. That's a nice angle. So 0.866. So graphing that, we're going to look something like here. So if I try and trace this out, what we'll find is that going up, we're definitely not getting a linear curve. It's something oddly shapen. So what we can see is that the behavior of this sine function, as it travels around the circle, it doesn't increase and decrease at a linear rate. It sort of increases really rapidly and then slowly slows down when it gets to pi on 2. And on pi on 2 as well, it's almost like the shape of this circle here and the shape it traces on the other side, it's almost mirrored. So what's going to happen is it's going to go down ever so slightly and then start to really accelerate in its decrease towards 0 again. So what we'll find is that a sine function is mirrored across pi on 2. So it starts to go down like that. And going onwards again, if we keep sweeping our angle around, notice the sine function, it grows really fast again, but in the negative direction. It slows down and slowly starts to taper off and then grows aggressively back to 0. So what we can see is our sine function will look something like that, really rough, but similar. So this is the sort of expected behavior we'd sort of want to see graphing it over the 4 quadrants. Now notice that with the unit circle, it doesn't actually stop. So if we were going or spinning around and around, and say we had a value of 2 pi, once we reach 2 pi, we start over and start spinning around again. So if I go, say for example, 2 pi plus, and we'll say 2 pi plus pi, or no, pi divided by 4. It's actually the same as saying just pi over 4, so it keeps spinning around. So from that behavior, what we can see is the sine function, it doesn't actually have a fixed or let's say a limited range, no, not range, domain, but rather the function itself just starts repeating itself over and over again. So the range from what we can see here, or the domain I should say, the domain is simply all real numbers. So all real. And if say we jump over to OneNote Desmos and we want to graph it using this, notice the behavior of A. So what we've got here is we've got the grid paper that I was sketching the sine function of, but now we're back in Desmos. And what I'm going to do is I'm going to sweep the value of A across the full range of 2 pi. But to begin with, we'll go in the first quadrant here and observe the pattern that's been traced out. So we rise quite aggressively and then we start to slow down and approach, or slow down as we approach pi on 2 as we hit a value of 1. Now if I increase it ever so slightly again, so quadrant 1 and quadrant 2, notice the shape that's been traced out. So it goes up and then it goes down, but it's mirrored. So it's mirrored across this axis here. And finally, if we trace out the other two quadrants, look at the shape we get. So quite an interesting shape. This is what we call one period of the sine function. Now, as I mentioned, it doesn't end there. It goes onwards and onwards and onwards, onward to infinity. So there's no actual end to this function itself. But what we can see is between 0 and pi, we get a single trace of this graph. So a single trace of the graph. And everything outside of 0 to 2 pi, it just repeats itself. So what we say between 0 and 2 pi, we call that the period. And we also say that this function itself is periodic, and the reason behind saying periodic is because it repeats itself outside of its period of 0 and 2 pi. Now, regarding the cosine function, what you can see with the unit circle here is the relationship between sine and cosine is such that when the side here, or this adjacent side, is when it's really small, when it's really big, I should say, notice that when the adjacent is really big, the opposite is quite small. And as the opposite increases, the adjacent side, so this cosine here, it decreases. And when sine is equal to 1, or the opposite's equal to 1, the adjacent is equal to 0. So what we can see, it's almost like a reciprocal relationship, but not quite. It's sort of you could say, it's like an opposite relationship. So when one's big, the other's small. And another thing we can notice about it is when cosine is positive and negative. So in quadrant 1, it's positive. In quadrant 2, it's negative. So see, it's on the left-hand side of the y-axis, so in the negative x region. In quadrant 3, it's also negative, and in quadrant 4, it goes back to being positive. So seeing that the behavior of the sine function, what we can do is estimate the behavior of the cosine function. So going back over to here, if we change these parameters, so from being sine to, say, cosine, so if I type this in cosine, notice what happens. It's almost like the sine function, but it's been shifted to the left. It's been shifted to the left here by pi onto radians. So what we can see is the sine and the cosine function. This is the behavior of the cosine function, and this is the behavior of the sine function. Bringing the two together, what we can see is sine and cosine.